Hello everyone, Mr. Kaczynski with you. Got a study guide here for you, a little companion for you as you prepare for this solving quadratic equations checkup that we'll do. So let's get right after it. All right, first off, solve this equation by graphing. I mean, what we're supposed to do is right there in the directions, graph it. So let's go to the calculator. Let's go to y equals, and we'll just punch in x squared minus 3x minus 10. And hit the graph button, and we should just look for the x-intercepts to see where this thing, what its solutions are. It looks like -2 is one of the solutions. Yep. So I'm gonna grab my pen and I'll write that x is -2, but there's a second solution. It looks like 5. Yep, 5. So that's it. That's how you solve by graphing, especially when you have a graphing calculator. It's pretty simple. Okay. So, and then we're supposed to make a quick sketch of our graph. So let's do that. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Those are, I guess, the x-intercepts are probably the important part, right? So -2 is one of our x-intercepts. We might as well kind of label that. And +5, that's our other one. And then we'll just do a parabola that kind of goes like that. Good enough. I think that's good enough for a sketch because those are the important parts that we're looking for off the graph. Ready to do it again? Let's go dual screen here. And yeah, I'll go over here and do this. All right, so again, by graphing. So let's go to y equals, and we'll type that in, 2x squared plus 13x minus 7. Graph it. So let's see, when I hit the trace button, 1, 2, 3, 4, 5, 6, 7, it looks like -7. There we go. So x equals -7, that's one of our solutions. The other one's right there. 1 is too much and 0 is not enough. Somewhere in between there, maybe it's 1/2. Yep, it is. So 1/2 or 0.5, accept either one of those. Again, we're supposed to make a sketch of this, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Put one dot here at -7, put the other one right in between the 0 and the 1, call it 1/2 or 0.5. And, you know, we could go so far as to try and figure out what the vertex is, but I think those are the important things when we're solving. So just something like that would get the job done. All right, there we go. Moving on, solve this equation by using square roots. We've got to show our steps and write your answer as simplified fractions, integers, or radical expression. I don't think that radical expression is going to be necessary here. So the first thing I'm going to do is subtract 17 from both sides. Let's go to my home screen. Let's do 81 minus 17. That comes out to 64. All right, so that's step 1. When it says show your steps, that's an equivalent equation that has the same solutions as the equation above it. Then I'm going to divide both sides by 4, and I know that 64 divided by 4 is 16. Okay, so that's my second step, is divide both sides by 4. And then my last step, and probably the most important one, solve by using square roots, is to take the square root of both sides. But you got to remember, every positive number has 2 square roots. So this is positive or -4, okay? Positive or -4. Of course, we could graph it as a great way to check. So, but I guess I would have to graph it, I would have to subtract 81 from both sides. So I could just do it like that. And there's the -4 and there's the +4. So yeah, keep going. Solve this equation by using square roots again. All right, this one's a little bit different because obviously it's the a quantity, x minus 2, that's being squared as opposed to just a variable x in this one. All right, so let's divide both sides by 3 first. Let's get this squared piece all by itself. And 123 divided by 3 is 41. All right, then I'll take the square root of both sides. Square root of the left side is x minus 2, and the square root of the right side, it's not a perfect square, so I'm just going to leave it as plus or minus the square root of 41, which means that I'm going to end up with this situation where my answer actually is a radical expression. And the last step is just to add 2 to both sides. And I get 2 plus or minus the square root of 41. So could we turn that into a decimal? Yeah, of course we could. And that's what IXL asked us to put into the answer boxes. But we could just leave the answer like that as well. Let's take a second and let's graph it. So 3 parentheses x minus 2 squared. And then I got to subtract 123 from both sides. So it's minus 123 equals 0. So there's one of the solutions. There's the other one. If I hit trace, 2 minus the square root of 41. That's one of our answers. And that is right there, about negative 4.40. Okay, we'll just leave it as that though. And then let's do 2 plus the square root of 41, and that should be that one right there. Yep, about 8.40. 8.40. Solve this equation by using the zero product property. Okay, zero product property states that if the product of 2 factors is 0, then one of those factors has to be 0. So either x plus 4 is 0 or x minus 6 is 0. If x plus 4 is 0, it's because x is negative 4. Negative 4 plus 4 is 0. 0 times anything is 0. If x minus 6 is 0, it's because x is 6. 6 minus 0 is 0, and 0 times anything is 0. Obviously, if we graph this, it will have intercepts at negative 4 and positive 6. Hey, we got time. Why not? Let's graph it. X plus 4 times x minus 6. And I'm looking for its x intercepts. There's one at negative 4. There it is. And here's the other one at 6. All right, so it's in factored form. We can use the zero product property to solve it. All right, what about this one? What are its solutions? Well, either this has to be 0, and for this to be 0, I'm sure a lot of you identified the shortcut. You just take the opposite of that and divide it by that. So 3 times 2/3 minus 2 will give us 0, and 0 times anything is 0. Or we could do, oops, that's a very big comma. How about negative 3/4? So again, 4 times negative 3 divided by 4 plus 3, that's going to be 0, and 0 times anything is 0. Could we graph it? Of course we could. Let's take the time and do that. Let's see how all these things connect. 3x minus 2 times 4x plus 3. Graph it. So there's a negative answer and a positive answer. Hit the trace, 2/3. There it is. That's where y is 0 at 2/3 or 0.6 repeating, but we're going with simplified fractions here, 2/3. And then trace it again. Let's go negative 3/4, and boom, there's our other one. Okay, so those are our solutions: 2/3 and negative 3/4. 2/3 and negative 3/4. Solve this equation by factoring. You must show the equation in factored form to earn credit. So can we factor this? Well, lead coefficient's 1. So in that case, all we have to do is look for factors of negative 12 that add up to 7, or factors of 12 that add up to 7. Okay, 12. Well, 1 and 12, those don't add up to 7. 2 and 6, those don't add up to 7. 4 and 3, those add up to 7, but we got to use negative 4 and negative 3. Okay, so I could write this as x minus 4 times x minus 3 equals 0. And then, now that I've factored it, I can use the zero product property to solve it, and x could be 4 or 3. Solving by graphing would have been a great way to do this, but that's why I put in here that you must show the equation in factored form to earn credit. We'll graph it. Why not? We can graph all this stuff. So x squared minus 7x plus 12. Hit the graph button. There's the 3, there's the 4. Trace. 3 gives us 0, 4 gives us 0 as an output. Solve this equation by factoring. Well, on this one though, you got to remember the first thing that you always need to do is get it into what we call general form. So we're going to have to subtract 54 from both sides to get 0 on one side of the equation. So now I'm looking for factors of 54, factors of negative 54 that add up to 3. 1 and 54 obviously isn't going to work. 2 and 27, no. What's 54 divided by 3? I know it's divisible by 3. 18, 3 and 18, that's not going to work. 54 is not divisible by 4. 5, yeah, I think it's divisible by 6. 54 divided by 6, there it is. That's the one we need because they have a difference of 3. So if I use negative 6 and positive 9, that would be our factor. All right, our factors rather. So let's go x minus 6 times x plus 9 equals 0. That's in factored form, and now we can use the zero product property to see that the solutions are 6 and negative 9. Let's graph the original equation. X squared plus 3x, not the original, but maybe my second equation, minus 54. There's one of the solutions, negative 9. And there's the other solution, 6. Okay, so yeah, we could have used graphing to solve it. It would have been super easy, but so is factoring. It's not that hard. You guys can handle it. Solve this equation by completing the square. Oh, remember completing the square? So that's where we need to make this left side a perfect square trinomial. Okay, and we do that by taking half of the 8. Let's do that over here on the side. Let's do half of 8 squared. And that would be 4, and 4 squared is 16. Okay, so half of 8 is 4, 4 squared is 16. So I need to add 16 here. And whatever I do to one side, I also have to do to the other. So I'll add 16 over there as well. Okay. So now I can write this as a perfect square or a binomial squared, x plus 4 squared equals, we'll simplify this, 7. Then we'll take the square root of both sides. X plus 4 equals plus or minus the square root of 7. And then I'll subtract 4 from both sides. And this says to write your answer as simplified fractions, integers, or radical expression. So in this case, we got that radical expression. That's our answer. Could we turn that into approximate decimals? Yes, we could. We're not asked to do so. So we leave our answer as regular. Can we still check the answer? Of course we can. We can go to y equals. We can clear this one off. Let's graph it. X squared plus 8x, but I'm actually going to add 9 to both sides, so it's going to be plus 9 equals 0. All right, so let's graph that. So that's negative 4 minus the square root of 7, and that's negative 4 plus the square root of 7. Let's go trace. Negative 4 minus the square root of 7. Enter. Boom. About negative 6.65. About negative 6.65. But we'll leave our answer as exact. And then let's do negative 4 plus the square root of 7. And that's about negative 1.35. About negative 1.35. But we'll just leave the answer like that. All right, so no, I'm not asking for the decimals like IXL did. Solve this equation by completing the square. Okay, so we just did that, but we'll do it again. Well, the first thing is to get rid of that negative 15. So I'm going to add 15 to both sides and get that 15 over there. Now, when I graph this, I will graph the original. Now I got to complete the square. So we're going to take 6, cut it in half, and square it. 6 and a half is 3, and 3 squared is 9. I need to add 9 to both sides. That's the completing the square portion of this. All right, so I'm going to add 9 to this binomial, and I'm going to add 9 to the 15. So I'm adding 9 to both sides. Why did we add 9 to both sides? So that we could write this as the square of a binomial. And then it's just using square roots on both sides after that. So we just take the square root of both sides. I'm not sure why I used parentheses there. I don't need them. So take the square root of both sides. plus or minus the square root of 20, square root of 24. There we go. And then I subtract 3 from both sides. And that gives me negative 3 plus or minus the square root of 24. We've graphed every other equation and checked answers. I think we'd be silly not to, so let's do it. X squared plus 6x minus 15. Hit that graph button. It's a great way to get your decimal answers too, if you wanted them, because you can check and get the decimal answers at the same time. So I'm going to do negative 3 minus the square root of 24. It's about negative 7.90. And then I'll do negative 3 plus the square root of 24. And it's about 1.90. Okay. Should be noted that that could actually be simplified more, but we didn't get that into that too much this year. I'm leaving it for your Algebra 2 teachers. Got a few more to go. Here we go. Solve this equation by using the quadratic formula. You know the song, sing it. Okay, the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. All right, over 2a. Hey, there we go. Missed my tone. All right, so b is negative 1. Okay, so maybe let's do this. Let's go a equals 6. B equals negative 1, C equals negative 1. So now we can plug these things in here. So negative 6, I'm sorry, opposite of B, so that's 1, plus or minus the square root of B squared. B squared, negative 1 squared is 1, minus 4 times A times C. Let's go minus 4. A times C would be 6 times negative 1, or negative 6, all over 2 times A, which would be 12. 2 times 6 is 12. All right, let's keep going. This would be 1 plus or minus the square root of 25. I did the mental math, but I'll come over here to the calculator and do it. 1 minus 4 times negative 6 is 25, yeah. My lights went off. You know the video is getting long when the lights go off. All over 12. All right, well that is 1 plus or minus 5 over 12. So this is one of those situations where our answer is going to be simplified fraction or possibly an integer, maybe both, okay? All right. So 1 minus 5 is negative 4, so there's one of our answers, negative 4 over 12. Or 1 plus 5 is 6, 6 over 12, so there's our other answer. Those can both be simplified, negative 1/3 and 1/2. I think we would be crazy not to check our answers. So 6x squared minus x minus 1, graph it. There they both are. Trace negative 1 over 3, negative 1/3. Yep, that's one of the solutions. 0.3 repeating. We're supposed to do simplified fractions. 6 over 12. Yep, there it is. That's the other one. That's a 0. Solve this equation by using the quadratic formula again. So negative b would be negative 8, right? Plus or minus the square root of b squared. 8 squared is 64. Minus 4 times a times c. 3 times 2 is 6. All over 2 times a. 2 times 3 is 6. Please feel free, hit rewind, pause, come ask me a question. Ask Mrs. Kraft a question if you're in her class. We'd love to help you. So it's negative 8 plus or minus the square root of 64 minus 24 over 6, which is negative 8 plus or minus the square root of 40 over 6. And that's the answer, because the square root of 40 is not a rational number. So we'll just leave this as a radical expression. Let's graph it. Of course we're going to graph it. 3x squared plus 8x plus 2. Graph it. There's the two solutions. If I hit the trace, you got to be really careful. Watch how I type this in. I have to do parentheses, negative 8 minus the square root of 40. I have to hit parentheses to end my square root and then parentheses to end my numerator, all divided by 6. There's one of the solutions, about negative 2.39. If we wanted decimals, we could go with that. It's approximate answer. Let's one more time. Parentheses, negative 8 plus the square root of 40, end the square root, end the numerator, all divided by 6. And it's about negative 0.28, negative 0.28. Now, again, it should be noted, this can be simplified, not down to non-rational, or rational numbers, but it could be simplified a little bit more. Again, I'm not getting into that this year. Use the discriminant to determine how many solutions the equation has. Well, the discriminant, b squared minus 4ac. Okay, so b is 4, so we're going to do 4 squared minus 4 times a, which is 3, times c, which is 5. All right, we've done enough mental math. Let's use the calculator a little bit here. 4 squared minus 4 times 3 times 5. So that's negative 44. So since that's a negative number, there is no solutions to this. No real solutions anyway. Your Algebra 2 teacher will argue with us about whether there's solutions or not. There's imaginary solutions, but no real solutions. So there's no solutions. If we graph that equation, we're going to see that it never hits the x-axis. So 3x squared plus 4x plus 5, graph it. Yeah, see, it doesn't hit the x-axis, so there's no solutions. As opposed to this one, well, first off, on this guy, let's rewrite this. 2x squared plus 9x minus 12 equals 0. So now I can see what a, b, and c are. So b squared minus 4 times a times c. b is 9. 9. Square that and subtract 4ac from it. A is 2. And c is negative 12. Now, if we would have used positive 12, it would have given us a different answer. But here we go. 9 squared minus 4 times 2 times negative 12. This is going to come out to a positive 177, and any positive number has 2 square roots, so thus this has 2 solutions. And if we graph it, which of course we graphed every other problem, we're going to graph this. All right, if we graph it, 2x squared plus 9x minus 12. We're going to look for where this is equal to 0 twice. Don't worry about what they are. Okay, we've already solved enough. It just has 2. A ball is launched from a height of 4 feet with an initial velocity of 140 feet per second. Use the following object model to find out how long it will take for the object to hit the ground. Okay, well, we've never talked about this, so this is basically new. Here's the falling object model. The height of an object is equal to negative 16 t squared plus vt plus s. Looks really complicated, right? H is your height at any given time, t, that's what t stands for. T is always going to be in seconds. S is the starting height. Do we have that? From a height of 4 feet. There we go, 4 feet. So we know that is 4. The initial velocity is v, so that's 140 feet per second. Okay, so we'll go 140 times t. And this is the effect of gravity on an object. So it's always a constant of negative 16 t squared. So that's it. We just had to plug in that 140 and that 4. And we're trying to figure out for the object to hit the ground, that means we want its height to be 0. Okay, so you must show your model to earn credit. That's it. That's the model right there. That's the model. Now we're going to solve that. We can use any method we want. I could use the quadratic formula and do negative b. How about I'm just going to use a graph. I'm going to graph it to check it anyway. I'm just going to use a graph. Negative 16x squared plus 140x plus 4, and then I'm going to hit graph. All right, I'm looking for that number right there, okay? So it's about 9. It's really close to 9. Yeah, somewhere between 8 and 9. Watch this. There's a calculate function. Second, calculate the 0. I calculate the 0. It says left bound. I'm right now, my cursor, I can move it right and left, but right now I am left of the answer. So enter. And then it says right bound. If I just hit to the right once, it jumps. I know it's right of it because this y value is negative. I can hit enter again. If I hit enter a third time, it gives me the answer. The answer is t is about 8.78 seconds. Okay, could we have used the quadratic formula? Is probably the other way to do this. Oh, sure. Why don't we do it? So t equals negative b, negative 140, plus or minus the square root of the discriminant. I am going to cheat over here. I'm going to do the discriminant. B squared minus 4 times a, which is negative 16, times c, which is 4. Oh boy, look at that ugly number, 19,856, all over 2 times a, which is negative 32, right? So t is about, because we're going to punch this into the calculator now, negative 140 minus the square root of that 19,856, all divided by negative 32. There's my answer, 8.78 seconds. Now, you might be thinking, well, isn't there a second answer? Yeah, watch this though. Negative 140 plus the square root of 19,856. Enter, divide that by negative 32, and it comes out negative. You can't have negative time. It's not like we're going to go back in time to when before the ball was launched, okay? So that's it. So we could do graphing if you know how to use the calculated intercepts, or a quadratic formula is really your only other choice. All right, what about here? A ball is dropped from a height of 30 meters. Use the dropped object model. So just when we think we know the dropped object model, I'm going to change it on you, because with meters, the effect of gravity isn't negative 16. That's only for feet per second. It's negative 4.9 plus VT. Oh, that's t squared. I'm sorry. Oh, let's start all over. So negative 4.9 t squared plus initial velocity times time plus starting height. So what's our starting height? Dropped from a height of 30 meters. Okay, so plus 30 right here. And what's our initial velocity? Well, it's dropped. Oh, wait. Dropped. Okay, that means the initial velocity is 0. So this is the equation we need to solve this time. And again, we're trying to find out to hit the ground, 0. All right, so this is our model, negative 4.9 t squared plus 0t plus 30. Again, I'm going to show you that graphing method one more time. Negative 4.9 x squared. I don't need the 0x, I'll just put plus 30. Hit the graph button. So the negative one I'm going to ignore. Okay, we don't want to go backwards in time. All I care about is that. It's about 2.3. Second, calculate option number 2. Left bound. I want to get close to the intercept, but not go past it. So left bound, enter. Now I'll go past it. Right bound, enter. And then you hit enter one more time, and you got your solution. T is about 2.47 seconds. Pretty neat little trick, right? 2.47 seconds. Now, what's the other way we could use to solve this? Well, we could use square roots. So I could have done, all right, let's start here. 0 equals negative 4.9 t squared plus 30. How about I add 4.9 t squared to both sides? That'll give me 4.9 t squared equals 30. And then I'm going to divide both sides by 4.9. 30 divided by 4.9 is about 6.12-ish. And then I'm going to take the square root of both sides. So if I go second square root of that number, there it is again, 2.47 seconds. All right, I've talked long enough. Hopefully this is beneficial to you. I graphed every single problem. Some of them I did multiple ways. We learned a little something new about the dropped object model. Yeah. It's either negative 16 t squared plus vt plus s, where v is initial velocity, s is starting height, or negative 4.9 t squared plus vt plus s if you're dealing in meters and meters per second. All right. All right. I didn't want to get to the dropped object model, but it shows up on the exam once or twice out of 50 questions, so I threw it on there. All right. No biggie, no stress. Come see me with questions. I'd love to answer them, or message me through the chat. All right, have a good one.